Okay, we talked yesterday about how the numbers 1 through 10 and their squares and their cubes we're going to start calling similar numbers. So if I see that number 729, I'm going to recognize, hey, wait a second. That's one of those numbers that can be rewritten as, 9 cubed? Because whenever we talk about notation, that's what this topic is about. When we talk about notation, that means we can symbolize the same value in two different ways. So like the words I am can be rewritten as I'm with an apostrophe. Well, 729 can be rewritten as 9 cubed. They mean the same thing, just written different. Period. Okay, we already talked about how, hey, this is one of the notations where we have an index and a radicand. The index tells us how much do we need of pairs, or do we need a group of 3, or do we need a group of 4 underneath that radicand. We also talked about how this operation undoes exponents. So if we have something that is if we have something that's x cubed, we can take the cubed root of it to undo it. Just like multiplication undoes division, roots undo exponents. All right, we've already done these from yesterday. Let's just recap. 4th root of negative 16. Hold on, my bad. Okay, here we go. 4th root of negative 16, we discussed how, wait a second, looks like it could have been a 2, because this 16 breaks up into 2 times 2 times 2 times 2, a group of 4, but that negative throws it off. Not only that, but 2i doesn't work. Did we talk about that yesterday? Oh, okay. All right. So 2i doesn't even work. So this was a no solution. All right, let's go to the next. Let's practice these. So you need to put it in the form. Cubed root of 125, because the form is the nth root of a. You've got to figure out what times itself 3 times gets you to 125. To show you in detail, if you took 5 times 5 times 5, notice how you get a group of 3. So the answer is 5. So in the next one, we get 0. And then we're going to take the square root of 49. So what times itself gets you to 49? We all know that. We're looking at 7. All right. So now we're getting a feel of the square root. My bad, not square root all the time, but the nth root. What if we wanted the 4th root of 16? Well, we already said that was going to be a 2. What if we wanted the 4th root of 81, and so on? All right. So the nth root, this is the other form that we can write things in. My bad, back it up. Yeah, square root of 49. Oh, hold on. Good question. Shouldn't we have plus or minus? When we're solving and we put the square root in, we have to consider both of them, plus or minus. So here's the bad thing. Whenever it's indicated that you're finding the real nth root of a, that's a trick question. Only because some textbooks are like, if I'm just finding the real nth root, let's just stick to positive answers unless you have a cubed root of a negative. And then some textbooks are like, well, yeah, it would be plus or minus. So, ooh. Let's just realize if I was taking a standardized test, I got to be open to both ideas. So if I'm taking the ACT and it says check all that apply, I may have to bubble in 7 and bubble in negative 7. Oh, that would be hard. All right, so now let's go to, let's go to this notation. The nth root can also be written as a rational exponent, a to the 1 over n. A to the 1 over n. This is the other notation. So the two notations we're going to go back and forth with is nth root of a and a to the 1 over n. I could put an equal sign there. I just put double arrows for right now. Well, I guess we can put an equal sign. They mean the same thing. This is the other thing that may blow your mind. If I have a rational exponent, that is not a unit fraction, I can actually rewrite that in two different ways. I'm going to give you some time to write that down. That if I have a fraction exponent, this numerator is going to be the power every single time. The base, let's actually label these positions. The radicand should stay the same as the base. So this is called a base. And the radicand stay. So this numerator of the rational exponent stays as the power. I'm going to call that M position, the power position. The N position becomes the index of the radicand. And then I guess we could do like a little whoop, whoop. We're going to constantly be going from one form to another to see what's going to help me get an answer depending on how my brain thinks. If I'm better with my exponential rules, then I'm going to try to get everything in exponential form. If I'm better with my radical rules, I'm going to use radical form. That's what this practice is going to be about. Here we go. So, let's evaluate without using a calculator. We're going to start with exponential form and turn it into radical form. You do not have this down, write it down. There are several ways to rewrite 27 to the 2/3. We need to figure out what way is going to help us. I'm going to write a few forms down and we're going to choose which form will help me mentally do it without a calculator. These are all the forms I could rewrite this number in. But which one is actually going to mentally help? Oh, man, nobody stopped me. The 2 is the power. The 2 should always be the power. The denominator is supposed to be the index. Hold on. Now we're good. So my index needed to be 3. My power needed to stay 2 every single time. All right. Which form's going to help me? So it's the second form that I'm going to keep going with. Cubed root of 27 is 3. Now we can square that mentally. It's a 9. So 27 to the 2/3 is 9. That denominator becomes the index. So we could rewrite this as cubed root of 343 to the first power. So whenever we have a unit fraction, actually all forms kind of go the same route. We've got to figure out the cubed root of 343. So now, 81 to the negative 3/4. We got to figure out how are we going to manipulate this to the best of our ability. Do I leave it in rational exponent form or do I start putting it in the index form, the radical notation? So computing the 4th root of 81, we get 3. Now we got to take 3 to the negative 3rd power. So negative exponents flip the number. So instead of 27, it's 1 over 27. We'll continue this tomorrow.